This is the NECO Physics Practical 2023. The question number 2, which is on lights. In this case, it is the rectangular glass block. Now, one thing about NECO is that this is a prediction for the NECO Physics Practical 2022, one of the best. And we are provided with the following apparatus: a rectangular glass block, 4 optical pins, drawing board, drawing papers, protractor, 30 centimeter ruler, which a 15 cm can also serve, 4 drawing pins. Alright, we move over to the practical guide for this particular experiment. So this is a set of instructions that we should follow. Now, for this experiment, remember we are going to set up and trace out the outline, as we can see in the diagram here. All right, so the instructions for this experiment goes as follows. Trace the outline EFGH of the rectangle glass block. So this is the outline, as you can see, EFGH, which are the 4 corners of our outline, the 4 corners of our outline labeled EFGH. So after that, we are going to remove the block and draw a normal. A normal is a perpendicular line, straight perpendicular line, KL, cutting the face at S and Q. So it's cutting the faces of the outline at points S and Q as indicated in the diagram, such that ES is about 1/4 of EF. ES is about 1/4 of EF. Draw a line making an angle of incident 30 degrees with KS. The angle of incident is usually made with the vertical, as shown. Draw 4 other lines of angle of incident 35, 45, 55, and 65 degrees respectively. Now we have to replace the glass block carefully on this outline. Fix 2 pins P1 and P2 on the incident line, making the angle of incident 30 degrees. So we have 2 pins P1 and P2, 30 degrees with KS. By looking through the side HG, fix 2 pins P3 and P4. So P3 and P4 will fix the 2 pins. Remove the glass block. Draw a line to pass through P3 and P4 and produce it to meet HG at T1 and KL at X1 respectively. Measure and record ST1 and X1T1. Repeat the experiment for other values of incident 35, 45, 55, 65. In this case, measure and record ST1 and X1T1. Plot the graph of X1T1 on the vertical axis and ST1 on the horizontal and calculate the slope of the graph. These are the set of apparatus for this experiment. We have our glass block. That's our glass block. We also have 4 optical pins. 4 optical pins. Now we are also provided with a drawing board, or any flat surface can do. Now the next thing we have is our A4 paper. A4 paper, white paper, will be provided with that as well. Now we have our protractor to measure our angles. Now, to measure our angles, the points must coincide with that portion of the protractor to be able to measure angles accurately. And we also asked to come up with a 30 centimeter ruler, but 15 centimeter can do, and that is what we have. And we also asked to come up with 4 drawing pins to hold our paper to the board, but a sellotape can do that as well. So we are improvising. So from the procedure, we use our sellotape or the 4 drawing pins to hold our paper to the board, as you can see that. We are trying to hold the paper to the board so that it can be steady for us to be able to make our drawings on it. And once we are done with that, now the next thing to do is to trace the outline of our rectangular glass block or prism on the drawing board, and that is what we are doing now according to the procedures. Tracing the outline of the glass prism, okay, as you can see. And once we are done with the tracing, we can use our ruler to join any edges, to join the edges in case it was not properly traced out. Join the edges of your tracing with a ruler to make sure that it's properly traced out. So this is what we are supposed to do. So for each of the angles we are going to measure in the experiment, we are supposed to make a fresh tracing of the rectangular glass prism. So according to the practical guide, we are numbering the edges of the trace E, F, G, H. Then from EF, we are to measure or draw a vertical line about 1/4 of the length of the length EF, and that is what we've just done now. Okay, now we are going to use our protractor to measure an angle of 30 degrees. So the vertical line must coincide with the vertical line that we've drawn. The horizontal line on the protractor will also coincide with the horizontal line EF of our tracing. And the center point must coincide with the intersection of the two lines. That must be done for us to be able to measure our angle accurately. So we coincide the points and the lines as stated, and we read off angle 30 degrees. So from 90 there, we move towards the other way because the angle of incident must incline with the vertical. Okay, so we have our 30 degrees marked out. So we are going to join that to the point of intersection, and that's that. So we have our 30 degrees. So that's the incident ray. We've called a point S, the point of intersection there, we call it point X. So we attach our two, okay, we make 2 points there, call it P1 and P2, and attach the 2 optical pins on P1 and P2. So this is P1 and that is P2. So we've attached the 2 optical pins to P1 and P2, and we replace our glass prism on each tracing, as you can see. Then we'll move around and then look through the other side of the glass block of our tracing. Okay, we're going to move around and look through the other side of our tracing and see the reflection of P1 and P2. So we are turning around, we can see, looking through GH, the side of GH as the other side, we can see the the reflection of the two initial optical pins. So we are going to now place the other two optical pins P3 and P4 to perfectly align with the reflection we are seeing, and we've placed that. As you can see, it perfectly aligned with the reflection we are seeing there. We call those points P3 and P4. All right, so that's that. All right, so we take off the rectangular glass prism and our optical pins, then we join the lines as instructed in the diagram in the practical guide. Okay, so we call these points P3 and P4. Okay, and we will join P3 and P4, okay, and project it to touch the vertical line. Okay, as you can see, we join P3 and P4 and then project it to join the vertical line as indicated in our diagram. We join the vertical, it will meet the vertical line KL, and we call that point T1. Then we now join point T1 to S. We join point T1 to S. As you can see, we join point T1 to S. So this looks similar to the guide that we have. So we call this the projection on the vertical line, we call it X1. Now we are going to take our measurements. So we are going to measure ST1, and when we measure ST1, we are going to use our ruler to do that anyway. So we position our ruler, as you can see. So the length ST1 gives us 6.6 centimeters. So we'll keep that record. ST1 is 6.6 centimeters. Now we'll go over to X1T1 and measure it. So when we measure X1T1, it gives us 3.7 centimeters. So we have that record down. X1T1 is 3.7 centimeters. So we are going to form our table of values. We have the incident, the angle of incidence, okay, as I, and it's in degrees. Then we have XT1 in centimeters, and we have X1T1 also in centimeters. Okay, so our fixed value here, the angle of incidence is 30 degrees. So we can put 30.00. Now ST1 is 6.60 centimeters and S1T1 is 3.70 centimeters. So we have that. Going to the second drawing paper, we must have traced the outline of our glass prism, okay? And then we have to draw our vertical line KL. So with our protractor perfectly aligned, we will measure 90 degrees. We will mark out 90 degrees. And from there, we can be able to join and produce our straight line. Okay, the straight line KL. All right, now I'm going to measure the next angle, which in this case, I'm going to measure angle 45 degrees. On purpose, 35 was skipped because of time constraints, and it will not affect the value of our experiment or the results we will get. So this is 45 degrees. I will join the line of incidence, which shows the incident ray. So this is 45 degrees. Now I'm going to attach our two optical pins on any position of our choice on the line of incidence. They are still P1 and P2. So that's P1 and that other one is P2. Now I'm going to replace our glass block on the outline, okay, and move over to the other end and watch the reflection of the P1 and P2 optical pins on the other side GH and attach P3 and P4 to perfectly align with the reflection of P1 and P2. As you can see, now we have indicated the points P3 and P4 and we've joined our lines. Okay, P1, P2, P3, P4. So we are going to join line point P3, P4 and project it to meet the vertical line KL. As you can see, that's the projection. Then that's joining line P3 and P4. Okay. And we call this one X2 because this is the second one we are doing. And we are going to join this point to S. Okay. And let's call this intersection T2 because this is the second one we've just done. Okay. All right. So, and we are going to measure ST2 and X2T2. So when we measure ST2 is going to give us 7.2 centimeters. So ST2 is 7.2 centimeters. We'll take that down, 7.20 when the angle is 45 degrees. Okay. So we are going to measure X2T2 and with our ruler, when we place it on the line and measure S2T2, we are going to have 4.4 centimeters. So X2T2 is 4.4 centimeters and we record that down, 4.40. All right. So we are done with this one. We go to the third one when the angle of incidence is 55 degrees. All right. So we trace the outline of our rectangular glass block on a paper. Okay. Then mark out the vertical line KL, which is about 1/4 from 1/4 of the length EF. And we've done that. Then with our protractor, we are going to measure angle 55 degrees. So from the vertical, which is 90, we are going to count backwards. 2, 3, 4. No, there's a mistake somewhere. So we are going to count again. So 10, 20, 30, 40, 50, and 55. Yeah, that's it. That's 55. So we are accurate now. 10, 20, 30, 40, 50, and 55. So that's 55 degrees. That's the accurate point. So we will join it to that place. Okay. So we will attach our P1 and P2, the two optical pins P1 and P2, and replace our rectangular glass block to each position. And then we will watch the reflection of P1 and P2 from the other edge of the rectangular glass block and position P3 and P4 to coincide with the reflection of P1 and P2 as we've done previously. As you can see, we've positioned P3 and P4 to coincide with P1 and P2. So we are taking away the rectangular glass block and our optical pins. So here is P1, P2, then this other side is P3 and P4. So we are going to join P3 and P4 and produce it to meet the vertical line KL. So joining P3 and P4, okay, and producing it to meet the vertical line KL. All right. So we are going to call here X3 because this is the third one we are doing, okay, and we are going to join this point to this other point, okay. So we call here T3 and we call here S. All right, so that is that. So the next thing we are going to do is to write down our value. So when the angle there is 55 degrees, so let's see what the length gives us. So when we measure the length, ST3 is going to give us 7.8 centimeters. So S33 is 7.8 centimeters, and when we measure X3T3 is going to give us 5.2 centimeters. So X3T3 is 5.2 centimeters. So we go back to our table of values and we put those points down. So when the angle of incidence is 55 degrees, ST1 is 7.80 centimeters and X1T1 is 5.20 centimeters. Fast forward to the last one when the angle of incidence is 65 degrees, and carrying out everything, we have that ST1 is 8.40 centimeters and X1T1 is 6.00 cm. For our graph plotting, we are looking at the title of the graph, which is very important. Our graph must have a title. So this is a graph of X1T1 against ST1. And the scale there shows 2 cm to represent 1 unit on the vertical axis and 1 cm to represent 1 unit on the horizontal axis. Now, our table of values at the corner there, you can see uniform number of decimal placements, and each of the fields or attributes have their respective units. So we can see that the vertical and horizontal axis of our graph have the corresponding dimensions and their units. Very, very important. Okay, so moving straight to plotting our points. When ST1 is 6.0 centimeters, X1T1 is 3.7 centimeters. So we mark out the points. As well, when ST1 is 7.2 centimeters, X1T1 is 4.4 centimeters. We mark out the points as indicated. Now, when ST1 is 7.8 centimeters, X1T1 is 5.2 centimeters. We mark out the points. And lastly, when ST1 is 8.4 centimeters, X1T1 is 6.0 centimeters. We mark out the points. Now, joining these points with one straight line, we call it the line of best fit. So, and that is the slope of the graph. So to calculate our slope, we simply take a convenient right angle triangle of our choice, and in this case it is indicated by the yellow line. That's our own convenient right angle triangle. You could choose you could choose any one you want. You could choose your right angle triangle from any point on the graph there, but make sure that they are easily read out to help you calculate your slope appropriately. So moving on to the slope of the graph is change in the vertical axis divided by change in the horizontal axis. So here is 6 minus 0 divided by 8.4 minus 3.85, and evaluating that, we have this is 6 over 4.55, which is 1.32. 1.32. That is the value of our slope. Now the slope has no units because it's dimensionless, because the centimeters cancel each other out. So the slope has no unit. Very, very important. So what does the slope of this graph signify? Now we can recall that the refractive index of a glass block is 1.5. The refractive index of a glass block is 1.5. So this slope represents the refractive index of this particular glass block that we use for our experiment. So that is what this experiment is all about, to find the refractive index of the glass block that we are using. So I hope that you find this video informative and educative. I would like you to hit the subscribe button and the notification icon for more videos coming your way. Thank you.